Page 57. We've seen this. I've explained it more than once, okay? Graphing, yes, you're going to have some questions like that on your test, which is not for a while. This is a definition of average speed. Remember where we started? Right in the beginning of kinematics, at average speed, I said, okay, you got one test, you got 50 on it. You got another test, you got 70, and everybody could tell me the average. Didn't even have to calculate it, right? That's exactly what this thing says. Only now it doesn't say your mark, it says average speed is initial and final divided by 2. That's your first test, that's your last test. Divide it by 2. You only had 2 tests, okay? Nice course. All right, I'm not going to go through all the details here, but what they're doing is just rearranging some of these formulas. You know this one, we've been working with it. Substitute that in here, and now you have a new physics formula. That's the big mama. That's the one with distance, acceleration, time, initial velocity, and it's a quadratic. It's got a square there. Okay? T squared. So if you've been through Math 11, maybe you know eventually how to solve this thing for t, but we won't be doing this today. Okay? Solving a quadratic, you can use a quadratic equation. So there's one main formula. Rearrange a couple of more. Let's substitute for t, and that's the only formula that doesn't have a t in it. So if you don't know the time, maybe you can try to get it, but maybe you just want to use that formula. Okay? So, there's our formulas. They're on the back of our book, with the exception of this one's not there. So when you're doing these questions, do yourself a favor, don't look up here, just look on the back of your book, because I'm not giving you this. You can only use the back of your book. And when you get your final test, I add a couple of more, but basically, what you see back here, that'll be your formula sheet for your final exam. Okay, what this all is, well, this is on there. Right, we know that. That's just our speed formula. And we also know that average speed is initial and final divided by 2. All they're doing is substituting this in there, and that's the same as this, isn't it? Distance is average speed times time, okay? So you got that one, you got that one. All they did was put them together to get that. Okay, so like I said, when you're doing these questions, the ones on the next page, just look on the back of the book, okay? Don't flip here. Do yourself a favor. All right, same thing. Write down what you know, solve for what you don't. Every question, you do this. Because they're not all going to be multiple choice. This is a written question, it's 2 marks. You can still get 1.5 by getting it wrong. As long as you do everything correctly, write down the steps, the appropriate formula. Okay? So, what do we know? What is the initial velocity? Stop right there. What am I getting asked in this question? What is the initial velocity? That's VO. Of a car accelerating east at 3 meters a second squared, what is this number? Yes, and it said it. But again, if you didn't know it, just look at the units. That's all you need to see. I should be able to just give you that number and you can tell me that's an acceleration. Because that's meters a second squared, not meters a second. Okay, I haven't even read the thing yet, right? I'm just picking up my information. 4 or 5 seconds, obviously that's a time. Okay, do I need to convert anything here? Or am I all in the right units, the ones that I want? Is this all SI stuff? Yeah. Yes, no kilometers, no hours, no minutes. Okay, hopefully after that first quiz, we're training your brains into looking for that sort of thing so you don't get it wrong. Finally, reaching a final velocity of, that's VF, 25 meters a second. Now what's this east stuff? That's east, this is east. Looks like it's the same direction, doesn't it? Okay, I'm not trying to confuse you here. So that's kind of redundant. Don't even worry about it. It's just now I can call it a velocity because I have a direction, right? All right, there's my information. Some of the hardest things I see with kids in Physics 11 is, well, what formula do I use? And again, I can't tell you every time. You got to get in the habit of figuring it out on your own. Okay? Which formula has these four things? This one? No, I don't have a distance. Right? This one? No, still no distance. Oh, that one's got distance too. This is the same one we've been doing. Right? Check. VO, yep. A, yep. T, yep. And I can only have one variable. That's the one I want to solve for. So next step, write down the formula without substitutions. Finally, make substitutions. It's already solved for what I want to find out, VF. Oh, sorry, no, I want VO, don't I? I got to solve this thing for VO. Okay, this is some grade 9 algebra. I want this thing in terms of VO. So if I minus AT from both sides, then I'm left with VO equals VF minus AT. Okay? So that, obviously I expect you to know how to do that. This is Physics 11. So VO, I'm just going to put all this stuff on the right now because that's the same as this, right? It's not a new formula, it's the same formula, it's just rearranged. Now let's go up there. What's VF? 25. What's A? 3. What's T? 5. Okay, it's just like Lego. Plug the stuff in the right holes. I don't even need to write units because I know it's all in meters and seconds. So what's 25 minus 15? 10. Now what's the units? V, that's a speed. I'm trying to find the initial velocity, 10 meters a second. That's actually a speed. So if I'm really picky, well, it's east, okay? Now I got a direction, it's a velocity. But don't worry about it. Okay? All right, so that should be same stuff we were doing yesterday. Second one. If we assume acceleration is uniform, well, like I said, that's the only acceleration you guys are going to get. Okay, and even if you go to university and do a physics degree, that's only the only acceleration you're going to get. Uniform acceleration, so it's kind of redundant. How far, what's it asking me? Let's keep reading. How far does a plane travel when it lands at 16 meters a second west and comes to rest in 8 seconds? What am I getting asked? What is how far? Distance, yes. Okay. It lands at 16 meters a second, comes to rest in 8 seconds. Well, let's start with the easy one, times 8 seconds. Which one's VO and which one's VF? That's a little trickier because we all speak English. And it's a little confusing at times. Comes to rest means stops at what speed? 0. Okay? Comes to rest. VF is 0. That we need to get familiar with. Lands at, well, if that's VF, then this one must be VO. Okay? So that's step one. Write down what we know and write down what we're trying to solve for. Read the question 5 times if you need to, but this you got to come to terms with, okay? I can word a question 10 different ways. Some are pretty explicit, other ones are pretty ambiguous. All right, second step. What formula do you want to use? I'm solving for D. Does the first one have D? No, not going to help me. These all have D. What else? Do I want to try this one? Why not? Ah, no acceleration. Can't use that. How about this one? It's got acceleration too. I must be using this one, and that's the one that's not on the back cover of your book. Okay? So it kind of generate on your own. D is VO plus VF over 2 times T. Okay? You got to put these two together. So that all that says is what's the average speed times the amount of time I'm doing that speed for, and that's given me a distance. So 0 and 16 over 2, that's 8 times 8. What must D be? 64. What's the units for a distance? It's got to be meters, okay? I already double checked. I should have said that. Everything here, well, there's only two numbers. It's all meters and seconds, okay? No conversions to do here. All right, any questions with that? Okay, if you like brackets, feel free, but make sure you don't make a mistake when you're putting that in your calculator. Okay, third and final question example today. What is the stopping distance, let's just read it, of a car if it accelerates at that negative 9.29 and has an initial velocity of 100 kilometers an hour? Okay, initial velocity, that's what that says. What do I want to write here for a number? What's the first thing I want to do? Convert that. What's the quick way to convert kilometers an hour? Because I want it in meters a second. Divided by 3.6. So that is what? 27.8, just tenths is fine, okay? I need that in meters a second, so it should be the first thing I do. Well, that set tells me I got an acceleration, and if it's a negative, and if this is positive, like I said, more importantly, that's in the opposite direction, then this thing must be slowing down, right? That's all I got. What does this mean? Coming to a stop. And it's also saying what? What is the... Yeah, see how that's funny in English? I'm saying two valuable pieces of information here in two little words. What is the distance if it comes to a stop? That would be easier to understand, right? But it doesn't say that. It says, what is a stopping distance? It's a terrible language, but we're all stuck with it. Okay, so now I got to scroll up and down here, so it's kind of tough, but I got VO, VF, A, and D. Which formula do I want to use? Top one? Time. Do I have a time? I need to solve for a D, so I got to have a D, so it's got to be one of these three. That doesn't even have D. Do I have time? No. See, I can't have two variables in one equation. It's not going to work. Okay? Can't have time. That one's got time too. So I'm using the last one. Okay? VF squared is VO squared plus 2AD. It's been a while since I wrote that down. Okay, if that's a 2-mark question, guys, you got 1 out of 2. Okay? Reese. Yeah, there's lots of ways to do it. You could do that and make it a 2-part question. Yep. Okay, what am I solving for? I'm solving for D. I got to sort this thing in terms of D. Like I said, Reese said, is there another way to do this? Yes, there is. Solve for a time, then solve for D. Okay? It's not wrong. There's lots of ways to do it. So, first, let's subtract that from both sides. Okay? Then divide by 2A to isolate D. So D is VF squared minus VO squared all over 2A. Okay? So what's VF? 0. What's VO? 27.8. All over 2 times negative 9.29. So, BEDMAS says I want to do that first. Right? Take an exponent before you take the minus. That's not in brackets here. So that's 772, 84 negative. And down here, that's not 2 minus 9.29. It's 2 times negative 9.29. So that's negative still, 18.58. That's important because what's a negative divided by a negative? Positive. And I'm solving for a distance here. So I could have a negative distance, but that probably doesn't make any sense. So what's that divided by that? Let's go down here. I know it's positive, and I got 41.6. Distance is in meters. Let's reword that. That's how long it takes to stop a car traveling at 100 kilometers an hour if it has a deceleration of almost 10 meters a second squared. Okay? Does it seem reasonable? You know what 100 kilometers is like, right? I don't know what 9.29 means when I hit the brake pedal, but does that seem like a reasonable distance to stop a car from 100K? Sure. Do you guys have any idea how long that is?
15% long.
Okay, but visually, very good, Calvin. Visually, do you know what 150 meters looks like? Because isn't that one of the questions in the driver's learner's road test? That's how far you need to be from someone before you click the high beams down? That's one of the questions. That's stupid. Because you know when you're supposed to do it? When you see the oncoming car. How many grade 10s do you think actually know how far 150 meters is, visually, looking down the road?
Probably less than that.
Yes. Isn't that ridiculous? Anyway, that's my pet peeve. Always look at your answer. Make sure it makes sense. Okay, 62, 1 to 6 and 8. I just have to point out something about number 6. Otherwise, you guys will be asking me anyway. So go to number 6. How do you like them units? Kilometers per hour per second. Yeah, so let's do ourselves a favor and just the kilometers per hour part. How do I make that meters a second? Divide by 3.6. So if you do that, then it'll be meters per second, which is what we want, meters a second squared, right? So 5 divided by 3.6 will be 1.39, okay, meters a second squared. Just write that there. I'm not here to confuse you with the funny units. That's the deceleration, or negative acceleration if you like, okay? But the better thinking is it's in the opposite direction as the speed, therefore, because that's positive, we're talking about this thing slowing down. Yes. Okay. Thank you.